is so exciting to be back here in San Francisco with so many of our press and analysts and partners and friends in the audience. And welcome to all of you who are joining us across the world. We have a lot of new products and exciting news to share with you today, so let's go ahead and get started. At AMD, we're focused on pushing the envelope in high performance and adaptive computing to create solutions to the world's most important challenges. From cloud and enterprise data centers to 5G networks to AI, automotive, healthcare, PCs, and so much more, AMD technology is truly everywhere, and we're touching the lives of billions of people every day. Underlying architecture for our Instinct accelerators. It's designed specifically for AI and HPC workloads. CDNA 3 is our brand new architecture that uses a new compute engine, the latest data formats, 5 and 6 nanometer process technology, and the most advanced chiplet packaging technologies. At CES earlier this year, we previewed MI300A. It's the world's first data center APU. And what we have is our CDNA 3 GPU architecture with 24 high-performance Zen 4 CPU cores. Now, these are the exact same cores in our leadership Genoa processors that I talked about earlier in the show. And we also add with that 128 gigabytes of HBM3 memory, all in a single package. And what we have is unified memory across the CPU and GPU, which is frankly very effective, particularly for some HPC workloads. Now, this results in 8 times more performance and 5 times better efficiency compared to the MI250X accelerator that is in the largest supercomputers today. Now, MI300A has also been designed into supercomputers already, and it's slated for the 2+ exaflop El Capitan system at Lawrence Livermore National Labs. It's the most complex chip we've ever built, with more than 146 billion transistors across 13 chiplets. Now, you guys know we've led the industry with the use of chiplets in our products. And our use of chiplets in this product is actually very, very strategic. We created a family of products. So in addition to the MI300A product, with our chiplet construction, we can actually replace the 3 Zen 4 CPU chiplets with 2 additional CDNA 3 chiplets to create a GPU-only version of MI300, optimized for large language models and AI. We call this MI300X. Now, for MI300X, to address the larger memory requirements of large language models, we actually added an additional 64 gigabytes of HBM3 memory. So with that, Drew, I am super excited to show you, for the very first time, MI300X. Paying attention, you might see it looks very, very similar to MI300A, because basically we took 3 chiplets off and put 2 chiplets on, and we stacked more HBM3 memory. But what you see with MI300X is we truly designed this product for generative AI. It combines CDNA 3 with an industry-leading 192 gigabytes of HBM3 that delivers 5.2 terabytes per second of memory bandwidth, and it has 153 billion transistors across 12 5 nanometer and 6 nanometer chiplets. So, I love this chip, by the way. We love this chip. Great. Thank you so much for being here with us today.
Great to see you as well. Thank you.
Yeah, so much has been going on. You know, we've been on this long journey and partnership together. Can you talk a little bit about our partnership?
Absolutely, Lisa, and thank you for having me, and thank you for the opportunity of being here today. I'm excited to talk about our partnership and how AWS and AMD are continuing to collaborate to advance cloud technology for our customers. At AWS, we're constantly innovating on behalf of our customers and have built the most reliable and secure global cloud infrastructure with the broadest and deepest portfolio of instances to support virtually every type of customer workload. AMD and AWS have been on a journey together since 2018, when AWS was the first to introduce the AMD EPYC-based instance in the cloud, delivering 10% cost savings over comparable x86 EC2 instances. And as customers used and benefited from these instances, they requested additional AMD-based instance types to run a broader set of applications. And together, we've introduced over 100 AMD EPYC-based Amazon EC2 instances for general-purpose, compute-intensive, and memory-intensive workloads. And just last year, we introduced our first instance optimized specifically for high-performance computing-based AMD processors, HPC 6A. And that delivered up to 65% better performance over comparable EC2 x86-based compute-optimized instances for workloads such as computational fluid dynamics.
Dave, we love the work with your team. I mean, it has been such a journey over all of these years, and we love the 100+ instances. Now, the breadth of your offerings is amazing. Now, we always talk about what can we do with our joint customers, and how do they benefit from our technology? So can you tell us a little bit about customers?
Absolutely. So we have a broad range of customers, and they've benefited significantly from the cost savings with AMD-based EC2 instances. A few examples of how enterprise customers have invested these cost savings into innovation to improve their businesses include TrueCar, a digital automotive marketplace, one of my favorite tools. They sought ways to operate more efficiently and increase development velocity so they could invest the money saved into innovating for car buying experience. And TrueCar optimized its AWS cloud infrastructure by up to 25% from a combination of choosing the AMD instance family for its core infrastructure, as well as right-sizing instances with AWS recommendation tools. And Sprinkler, another customer, is a purpose-built web platform for businesses to manage customer experiences on modern channels. With the scale at which Sprinkler operates, it has to optimize its robust architecture for cost and performance. Sprinkler has been an early adopter of our first generation AMD-based EC2 instances for general purpose workloads, our M5A instance. And when they moved to Amazon EC2 M6A, the next generation, Sprinkler saw 22% faster performance and 24% cost savings over the previous generation. And then in the HPC space, DTN, they run weather and data models that deliver sophisticated, high-resolution outputs that require continuous processing for vast amounts of data from inputs across the globe. DTN uses Amazon EC2's HPC 6A instances, powered by AMD's EPYC processors, to run computer-intensive HPC workloads. And through the agility, elasticity, and efficiency of running HPC workloads on AWS, it has effectively doubled its high-resolution global weather modeling capacity from 2 times a day to 4 times a day.
I love what we're doing together with customers. It's really great to hear those examples. I think both AMD and Amazon, we really share this passion for enabling our customers to do more with our technology. Now, I'm even more excited, Dave, about what we're doing next together. So can you talk a little bit about what's next for our partnership?
Absolutely, Lisa. Well, one of the things we continue to see is increasing demand from customers to run workloads faster while getting better price performance in AWS. And to help address customer needs, we're building new EC2 instances enabled by the unique combination of the 4th generation AMD EPYC processors together with the AWS Nitro system. Now, the AWS Nitro system is the foundation for every single EC2 instance, enabling us to deliver performant, secure, and efficient infrastructure. And by combining the 4th generation AMD EPYC processors and the AWS Nitro system, we've unleashed the full capability of the next-gen AMD processors and deliver a significant leap in performance for our customers.